So for trusses, we have the two methods, the method of joints and method of sections. Both methods are going to be used to calculate the forces at the trusses, I mean in truss members. So first we are going to talk about the method of joints. In method of joints, what we are going to do, we will apply the load at the joints first. Like if you have uniformly distributed load or the uniformly varying load or any type of load, you're going to convert the load and shift it to the joints. And in this case, we are going to assume that our weight of truss is actually low or it's negligible. And members are connected through pins. So with these assumptions, we will apply the method of joints. And then we will assume that our structure or the members are either in compression or in tension. So we will assume that our compression our members are either in compression or in tension. Because once you are looking at the truss, it is important to understand the behavior of the different members, that how they are actually looking. And once, like before analysis, you need to look at the dimension and the geometry of the truss and see that how it is looking. And for that purpose, once you have seen that, by using method of joints, obviously we will solve the trusses. But for solving the trusses, we will apply the conditions of equilibrium. So how we are gonna solve it? We will apply the basically conditions of equilibrium, but before that you have to draw the free body diagram. Free body diagram means how many forces are actually acting. So if I write here the steps you need to follow for method of joints, while solving this kind of questions, first you have to analyze the truss members and analyze if they are in compression or in tension. Analyze truss members. Means you need to check if it is in compression or tension. You're gonna see that from the diagram, and then you can basically choose a particular sign. You can say that for compression, the forces are in negative sign, or in tension, you're going to show it with positive sign. So whatever the sign is, you have to just use it. So once you have analyzed the trusses, then calculate, basically you need to calculate or convert the loads or shift the loads to the joints, loads at joints. In some of the questions, you will see the load is already shifted to the joints, and for that case, you don't have to even shift it. So you can just solve it as it is. But in some cases, if the load is not shifted to the joints, you have to first shift it to the joints, and then you will solve it. Okay, and then once you have shifted the loads at the joints, you are gonna draw the free body diagram of the truss. Draw free body diagram of truss. In free body diagram, basically we are gonna show the reactions, that how many reactions are actually on the truss, how many forces are acting at the joints. So basically this is a whole representation of the forces. Okay. Then after that, you're gonna assume that some of the members are actually in tension or in compression. So do the inspection of the members. So do the inspection of members, and based on that, you are gonna assume the unknown forces. Assume unknown forces. So during assuming the unknown forces, you have to see that whether the forces are in compression or in tension. Once you have analyzed it, then you are gonna apply the condition of equilibrium. So apply the equations of equilibrium. Equations of equilibrium. So when you are going to apply the equations of equilibrium, you have obviously three different equations. It could be,
Sir, I have a question.
yeah.
So we have to determine two times like the compression and the tension.
Hmm.
So we have to do it first. So we have to like assume all the different parts, the compression and tension, and after we have to do it for a specific part.
In inspection, because we assume that in our truss, the members could only be in either tension or compression. So we have only two choices. So based on
Mhm.
this, we are going to just assume it. If even if your assumption is not correct, later on you will get the opposite sign and you can change it. It's not a problem.
Okay.
So once you have,
So first we have to, so when we have the entire truss, we have to choose on each part if it's compression and tension. After we have to like shift all the loads at the point. We do the equilibrium, etc. We drawing the free body diagram, and after that we do again the inspection because I saw that the first step was analyze trust members. So I don't know for the first step if it's the same or what is different between those two steps because it's about compression and tension again.
it's both are same, not big difference. But in first step, we are just checking the stress overall
Okay.
analysis, like where the forces are actually going, whether the forces are in UDL shape or whether they are at joints, what type of supports are there at supports, like how many reactions are there. If it's pin one, then you're gonna show the two reactions. If it is movement, like fixed, you're gonna show three reactions. If it is roller, so you're gonna see the three reactions. So instead of saying analysis of truss member for C or T, we say that we are analyzing the truss for reactions in this step. So see that how many reactions are there. So look at the supports. Now I think it's clear.
Okay. Thank you, sir.
So now first you have analyzed and looked for the trusses, then shift the loads at the joints, then draw the free body diagram. Then you can inspect the individual members. In individual members, tension compression for individual members. Individual members. So once you have basically assumed and inspected the elements for unknown forces or unknown types of or the direction of the forces, you just inspect individual members and then apply the equations of equilibrium. In equation of equilibrium, we are gonna usually apply two equations of equilibrium. So first one is sum of all forces along x-axis would be 0 and sum of forces along y-axis are going to be 0. So you can assume, as I mentioned earlier, that you can assume that your tension is positive or compression is negative. So here you're gonna choose the direction of the forces as well. Obviously, you will choose the type of the forces, like what force we are going or it is being applied, but you can also, this is related with this step. So you can say choose the sign of the force, sign of force. You can assume that your compression,
What do you
um,
mean by the sign?
sign means basically we have tension and compression. So in answers, sometimes you're getting negative number, sometimes you're getting positive numbers. So if you are getting positive number, then you say that it is in tension. Like if
Uh,
earlier you had made assumption, right? So you will say that over tension, basically in this step, when you said that when you inspected the elements and then you looked for basically the compression and tension. So here at the same point you also assume the design. So for tension we are saying that it is positive, and for compression we are saying it's negative. So this is basically our assumption. So you have just assumed it, and once you have chosen the sign of force, for compression we said that it is negative, and for tension first you assumed it was positive. And in your answer, if your answer is matching, like if your answer is also positive, it means that the assumption that you made earlier is actually correct. If it is not correct, it will give you opposite, and you can just turn and say that this is compression. For example, earlier you assumed that this member or this horizontal, just consider this truss simple, and here we have this support, and the force is actually being applied here. So now,
mhm.
if I assume that this is in tension and this is in compression, now if this is in tension, I am saying that this is positive. I am assuming this is negative. When I will actually solve the forces at each joint, so I am saying that this joint is A, this joint is B, and this joint is C. So when I will be calculating the force in FAB and FBC, if those forces, let's say that this was 5 kilonewton and this is 8 kilonewton. So in my answer, if I am getting the force in FAB, which is basically negative 5 kilonewton, and I have uh, positive 5 kilonewton or negative 8 kilonewton. So now compare it with your assumption. Earlier, I assumed that this was positive. Tension sign will be positive. So I got plus 5 kilonewton. It means that I was correct. Okay. However, if this was negative 5 kilonewton, then it means your assumption was not correct. Now turn this into C instead of T. That's what I'm talking about.
Okay, okay, thank you, sir. Perfect. Okay, so we will see deeper, I think, with the exercise after.
Yeah, so basically, initially you have to assume the forces because you actually don't know that what type of force is actually acting. But I will tell you a method through which you can actually analyze a structure and see that what types of forces are actually coming. Like I will give you the general method to analyze the truss and see that what types of forces are there actually, whether it is in compression or in tension. But in some cases, some forces are actually complex, like they are acting at certain angles or maybe at different positions or at different joints. So it is actually difficult for you to exactly determine or evaluate that whether it is in compression or tension. So for that case, you can actually just assume it. And once you have assumed the signs, get your answer and thus then match that answer with your original sign. If the both signs are same, it means your actual assumption was correct. If it is opposite, then you have to actually change it. This is the only difference here. So once you have basically applied the condition of equilibrium in fifth step, and then in next step you are gonna see its sign whether it is matching with our assumed one or not, and then in last step you are gonna repeat the whole thing, repeat the process for whole members, for all members. Is it clear?
Yes, perfect. Thank you, sir.